on point here so we can stay focused on some math. I'm going to shut the chat down, host only, so that you can ask questions if necessary. I believe we're going to adjust the schedule a bit to allow for something different to happen today. So I want to jump right in and get going with some math for today. We have been looking at some pre-algebra and algebraic expressions, algebra with variables. And real quick, variables, just to remind you, variables are letters that simply represent numbers. Letters that represent numbers. And expressions are algebraic expressions, specifically use letters and numbers. And we have done a few examples of what that might look like and how you can replace the letters with a number so that you can actually solve the expression. Now, there's a few different ways that you can write expressions, and we got to make sure that you understand how exponents fall into this and how you might write an expression using exponents. So I'm going to go ahead and flip over to my whiteboard here so I can share some examples with you. First example I would like to set up for you is just solving a few of these variable expressions, just to remind how to solve a problem with a variable in it. So let's start off with this one. How about 2d plus 3 if d equals 8? What if d equals 8? Then what would the answer be to this expression if you were to solve this expression? What's it worth? Yes, absolutely. Got lots of answers coming in quickly. Good job. You guys have jumped off the struggle bus this morning. I'm glad you are on it. If d is 8, this means 2d, which means 2 times 8 plus 3. 2 times 8. I put 8 in parentheses because if you remember, 2 touching a number means multiply it first. So 2 times 8, 2 next to a parentheses means multiply. 2 times 8 is 16, and 16 plus 3 is 19. All right, very good. Let's move on to another problem. Or sorry, expression. I don't want to give you problems. We already have enough problems. Let's go with, how about 4 minus 2f? And that's if f equals 1. If f equals 1, what would this be? Miss Bragg, we can't see. Uh-oh. Can you not see the question? Oh, if you're having a hard time seeing, please let me know. I will do something different. Okay. Oh, never mind. Okay. 4 minus 2f. 4 minus 2f. The answer, okay. I like how you said that. The answer is, yes, if f equals 1, that means 2 times 1 here, but you have 4 minus 2 times 1. And if 2 times 1 is 2, then 4 minus 2 is indeed 2. All right. So you are getting the hang of these expressions and solving these expressions. I'm going to go over something new here in just a minute. I just want to make sure that we have a good foundation here. How about this one? This one's going to look a little different. 9 over m plus 4 if m equals 3. Ooh, sideways. Oh, love this. Okay. 9 over m plus 4 if m equals 3. There you go. You guys are doing a fantastic job. So far, so good. Great. Man, oh man, you guys are good. Yes, you're exactly right. This line means divide. So if you have 9 over m and you replace the m, that means 9 over 3 plus 4 would be 9 divided by 3, or 3 plus 4, which is 7. Yes, everyone who has been plugging in answers, you guys are doing fantastic. I'm very impressed. I'm very proud. So far, so good. Now we have done just some regular or basic equations here, or expressions, I'm sorry. And I want to just throw a few more out here to you, because when you do today's lesson, you may see something that asks you to write or solve an expression with a variable that has to do a little bit with area and volume. So I just want to recap area and volume just for about a couple of minutes here. Area. The area means the whole entire space or the whole entire part inside of an object. Okay, so the area of a square is a side times a side. Okay, so if you have one side times the other side, that will give you the area, or side times side. Okay, now that's what it looks like. Now, the side of a square is always going to be the same. Okay, the side of a square is always going to be the same. And the reason I started with a square is because you will have problems with squares coming up in the lesson for today. And this square has the same side. Yes, you're exactly right. The area, more specifically, if it wasn't a perfect square, would be length times width, or base times height. Yes, area is length times width. Okay, length times width. Whatever the length is times whatever the width is. And what that would look like for the square for today, area equals the side squared. So you have a square going on here. If you have a square, that means you're taking this side times this side. And if I said, what is the area of this square if the side, any side you pick, because a square has equal sides, if a side is 10, if one side equals 10, then what would be the area of the whole entire square? And of course, a square means 10, this side times this side, which is 10 times 10, or that of course equals, there you go, 100. And if I said 10, I would have to use some kind of unit, like 10 centimeters times 10 centimeters. And if you have centimeters times centimeters, then you would have to say centimeters squared at the end, because you multiplied two, two length and width times each other. So you multiplied two sides, so you have centimeters squared here. All right, let's look at, yes, this takes me back. Oh, good, I'm glad you remember some of your area problems. What would be the area if I said this square, I'm just calling these squares right now because I want to know what's inside this whole thing. If one of the sides equals 5 inches, if this side is 5 inches, what would be the area of this square? There you go. No, not Tristan. Try again. Angel, try again. 5. If this side is 5 and this side is also 5, each side of a perfect square is 5 inches, then the area is going to be 5 times 5, which is 25. And that again is inches and squared. This is just how you label, because anytime you're given a problem that gives you a measurement, you want to use that measurement in your label. So you have 25 inches squared. Yes. All right. How about if I have the area of this square? I just want to review the areas for a minute here. If I have the area of this square where one side is 3 meters, 3 meters, then the area is what? You have this side times this side. Yes, there you go. Good job, good job. Of course, 3 times 3 would be 9 meters, and then you would say 9 meters squared to give it the proper label measurement. All right, there you go. Now you're getting it. Now that works with squares, and of course the area of a rectangle is just length times width, but we'll get into that when we talk more about geometry. I'm just looking at squares right now because you're going to be using some um, exponents when you're talking about some of your problems today. For example, if I'm going to give you kind of a word problem here. If the school wanted to build a four square, or wanted to paint a 4 square box on the blacktop. Okay, here's what a 4 square box would look like on the blacktop if you've played Foursquare. Um, and one of the squares, only one of the squares. So this square right here, just one of the squares, if you were standing inside this square, has a side that equals 5 feet. We'll say 5 feet. If one of the squares equals 5 feet, there you go. Then how much would that one square equal? If one square only equals 5 feet, how much is that green square? Just that one square right there. Yeah, absolutely. You would have 25 feet squared inside of this one, 25 feet squared. Now, how much area would you need for the entire 4 square box to be painted? How much area would you need for the entire 4 square box? Yeah, there you go, the entire thing. If only one of the 4 square boxes is 25 feet, then you have 25 times 4 because there's 4 boxes. Or you can say I have 25 feet squared there, 25 here, 25 here, 25 here. And in total, that would be 100 feet squared total. Okay, 100 feet squared total. Or you could have said, if only one length here is 5 feet, then 2 lengths would be 10 feet total. Okay, so if this was 10 feet, then you can multiply 10 times 10. So there's a multiple ways you can find out about squares and the area of squares. I just wanted you to be aware of that, aware of these kinds, because the area may show up in today's lesson, and I want you to be familiar with area, how to find the area of a square. Okay. The other exponent they use is to the third power, and that has to do with volume. Now, an area is two numbers multiplied together, a base and a height, a very basic base and height. Now, that's a two-dimensional figure. That means it's flat, okay? Volume is a three-dimensional figure. So if I were to draw a box, okay, this is supposed to be a box. It's a three-dimensional figure. Three-dimensional means you have a length, you have a width, and you have a height. Now you have 3 things that you have to multiply. And if this is a perfect box or a perfect cube, then you would say the volume of this means how much stuff can this box hold inside. If I were to fill it all up, all the way up to the top, how much would it hold? And that's the volume. And volume means length times width times height. So all 3 of these dimensions need to be multiplied together. And this is where you might see, if you have a perfect cube, a volume would be a side cubed, or 3 times, a number of times itself 3 different times. So for example, if I said a volume of a box, let me draw the box real quick here. Okay, volume of the box, if one side of the box is 20 inches, so the base, this length here is 20, the width is 20, and the height is 20. All of them are 20. You would say the volume of this cube is 20 to the third power, because you have to multiply 20 times 20 times 20. Oh, now I got some big numbers going on. 20 times 20 times 20. See if you come up with that answer real quick. No, you're not multiplying 20 times 3. The answer is not 60. You want to know how much, not just the front of this cube is, but how much the whole thing, 3 dimensions. So you're taking this cube and you're stacking it front and back. Yes, there you go. 20 times 20 times 20. That's going to be a very large number. Oh, this thing, I keep bumping it today. I don't know what's up with that. Maybe I have it down. 20 times 20 times 20. So volume of a cube. There you go. You have, and here's my little shortcut way. You have 3 zeros here. 1, 2, 3. So that's 3 place values already. 3 tens that I'm talking about. And 2 times 2 is 4. And then 4 times 2 is 8. So 8,000 would be the volume. 8,000. And you would label it inches cubed. Inches cubed, because you had to multiply 3 things times each other this time for a 3-dimensional object. Okay. So a 2-dimensional object is flat. So this one was 100 feet squared because you multiplied 2 things times each other, okay, a length and a width, or a base and a height. And then down here for 3-dimensional volume, you multiply 3 things. So in this box, or cube, I'm sorry, I'm saying cube because I want it to be a perfect rectangular prism here. This cube, if you have a side of this cube that is, let's go with 4 inches. This is a smaller box, okay? If you have, thank you, Zanaya. If this side is 4 inches, what would the volume of this cube be? Yep, this one's taking a little longer. Because volume, you do have to multiply 3 things by each other. So it's supposed to be a 3-dimensional object. So you have 4 here, 4 here, and 4 here. 4 on the length, 4 on the width, and 4 on the height. So yes, exactly. 4 times 4 times 4. And yes, if you're doing 4 times 4 times 4, that is 64. And then you would say inches cubed to label it correctly. Inches cubed, because you multiplied 3 dimensions by each other, the length, the width, and the height. Okay. These 2 types of problems, I just wanted you to be aware because they do use exponents, and I wanted you to be prepared for the exponents and just be familiar with these 2 formulas here. Okay, the formula of an area of a square. Okay, so the area of a square would be the side times the side. So it's a 2-dimensional object, and you multiply one side times the other side. And the volume of a cube, 3-dimensional figure here, is going to be side times side times side. So 3 sides, because you have 3. Oh, okay, interesting. I'll remove that. There you go. So the volume is 3 of the sides, or 3, or the side to the third power. So if you see this, just to be aware, it's the same thing as using exponents here. All right. I wanted you to be aware of those, and then the problems that you solved in the beginning of the hour as well, or the beginning of the lesson as well, are the 2 different types of problems that you're going to see today. Now, your assignment, oh, something's going on with how the screen is showing. All right, gallery. There we go. All right. I just wanted you to be aware of these so that you can do your iReady lesson, your lesson for today. Your practice is in iReady. I do want to give you a good 10-minute head start here on the iReady lesson. We are going to have shorter breaks so that we can get through more of the lesson quicker and give you some time to practice on these things on your own as well. So this lesson is called Write Expressions and Variables. Okay, write expressions with variables, I believe. Write and evaluate, sorry, my bad. It's called Write and Evaluate Algebraic Expressions. Write and evaluate algebraic expressions. Now, if you I have a couple of people who said, what is happening? I've been disconnected. I'm just getting back on. I will post a mini lesson in Khan Academy. If you need to see some more of this type of example, I can post the video in Khan Academy so you can see it again. My goal, here's my goal. My goal is for you to finish 2 lessons every week in iReady. So today's lesson in iReady, the practice is supposed to take about 20 minutes. If you finish the whole lesson today, great, then you are done in one day. If it takes you longer than 20 minutes, then you can use 20 minutes today and 20 minutes tomorrow to finish that lesson, however long it takes you. You have to finish it within 2 days. That way we can build on this lesson and keep moving forward in math, okay? So if you say, do we have to do the first part or both parts? I'm going to say you have to finish the whole thing, part 1 and part 2, okay, the lesson and the quiz, within 2 days. If it takes you 1 day to finish, then finish today. If it takes you 2 days to finish, then finish tomorrow. If you start it right now and you finish it tonight for homework, then you are ahead of the game and you are doing everything you can do to have your best learning. All right. So I'm going to give you, we're actually going to start the next lesson at 9:15. So you have a short time to start this lesson. All right. And after you start the lesson, then you can finish it for homework. Okay, I will write here what the lesson is called so you can see it. So iReady lesson. Write and evaluate. Oops. There we go. That's what it's called. The iReady lesson is write and evaluate algebraic expressions. So do that first, or at least get logged in. Let me close my door. All right. Oh, sorry about that. I had to close a couple doors. All right. Yes, you're correct. It says no assignments in Khan because I have not assigned it yet. I'm going in right now. And I will give you mini lessons here with exponents. There you go, videos. And we're going to get into all of this week. I'm going to go ahead and post a couple of videos and articles. Now, these are for the week. And if you need to see the videos, it's going to cover all the lessons for this week. And they are optional in Khan Academy. There we go. Oops. Put due date, wrong due date. Dang it. See if I can change that for everybody. Oh, what time is it for real? Yes, that is correct. I posted 2 videos and some articles. The articles are just real quick snapshots, kind of like notes. All right, the notes in Khan Academy for the next couple of lessons. All right. But you have all week, you can watch them, you can go back and you can look at them again. But if you do the assignment that's in iReady, it is going to go over the lesson again with you as well. And it will kind of explain to you as you go along. And it does build on it, build on each other. So these iReady lessons will build on each other. That's why I'm thinking 2 a week ought to be good. And that's my goal. And that should give you your 20 minutes of math each day to practice. And if you get through more than that, then fantastic. But that should give you your time and your lessons. And it will help you with your time. Oh my goodness, I am so distracted. All right. So you have about 10 minutes that you should go ahead and finish, or about 8 more minutes, I'm sorry, that you should go ahead and finish. And then you get a 5-minute break, and then we will go into the next lesson. If you have questions, the chat is open. I am happy to help you out.
We are surveying something. Oh, now I'm using a word that we might know, like when we survey a text. When we survey something, what do? Maybe these 2 words are related. Okay? So give me your whiteboard. Show me your answers. What do you think surveillance means? Sorry, I do that every time. To watch. Good job, Miss Hoskins. I think that's a good guess, a good substitution. Another one. To spy. Rosalind, I think that's a great one too. I think spy might have some connotations that might be a little different, but it's a great guess. I think that's a good guess. Any others? To be watching, Drake, thank you. No one else? Security, a strong system. Good, I like these. Yeah, surveillance means to watch without them knowing. To watch somebody without them knowing, okay? And so spy actually is a good substitution. Watch would be a good substitution. Remember, survey itself means to look upon something. So we have an idea of what surveillance means. And usually when we talk about surveillance, we are talking about cameras, we're talking about audio recorders, they're used in security systems to watch and make sure everything is secure. Let's go to another word. This one's on page 13. On page 13, I want you to find a word that starts with the letter P. P. This one is rather obvious because I think there's only one word that starts with the letter P. What is it? That's right. It's peculiar. It's at the very, very first sentence. It's very peculiar. Let's clear our minds by doing something else. So if we're going to read through it right here, we would have to go back to page 12 and we'd have to read through it. How was it? It was fun, but we overheard some people talking about us. Then one of them say, be careful, they're trouble. That's very peculiar. Let's clear our minds by doing something else. So we've read through it. Peculiar might be a word that you know, but you just don't use in your writing, or it doesn't show up very often in your reading. What's another word we could substitute then for peculiar? Strange, absolutely. Strange is a strong synonym of peculiar. See if there's any others. Anybody else have something other than strange? Strange works really well. So I see a lot of strange. Weird, oh, that's a good one. Isabella, way to go. Weird, that's really, really strong. Weird and strange, good. Yeah, weird or strange, that's very weird. It's very strange. It's very peculiar. See how all of those pretty much say the same thing, okay? So let's go to another one on page 16. It's over here. And this one starts with the letter E. E. Find a word that starts with the letter E. Write it on your whiteboard, share it with me. Sorry. I'll give you a clue. It's in this area right here. What's the word? Starts with the letter E. Episodes. Thank you, Mason. It's the only one. I know every, but we know what every is. So it has to be episodes, isn't it? Episodes. I don't know. All I know is that the audio tapes have recorded episodes of the person breathing 4 times. It happens every few days at the same time, just after the museum closes. What's another word we could substitute for episodes? Another word we could substitute for episodes. Tapes? Drake, that's a good guess. If I was to put tapes in there, would it make sense? All I know is that the audio tapes have recorded tapes of the person breathing 4 times. Kind of makes sense. Okay. Have you ever heard, make a connection, try this. Have you ever heard episode used before? Where have you used it? Where have you heard it before? Occurrence. Recorded occurrences. That makes sense. Carolina, good job. That makes sense. I hadn't thought of occurrences, but that's a good substitution. I might have used the word sessions. All I know is that the audio tapes have recorded sessions of the person breathing 4 times. It means different time periods. It happens, okay? So different occurrences would have worked very, very well. Recorded occurrences. Let's go to another one. We only have 2 more. I want to go to page 22 this time. Okay, this one starts with the letter M. M. I'll give you a clue. It's up here in this corner this time. Okay, the letter M. What's the word we're looking at? You may not even know how to say this word. Might be something you've never seen before. That's right, Rosalind, it's mannequin. Right here, mannequin. At the center of the gallery was a mannequin on a raised platform. Now remember, this is a graphic novel, and so the clues are in the pictures. At the center of a gallery was a mannequin on a raised platform. So if we look at the picture, here's the raised platform, and here's the mannequin. So a mannequin is a figure or a dummy or a manufactured model, thank you, Carolina, of a person, of a human being, right? That usually has clothes on it to show something. We see these all the time at the department stores that show something that maybe we want to buy. There's one more word we're going to look at, and it's on page 23. And this one is right in here. And it starts with the letter A. You don't have to find it because I'm going to tell it to you, okay? And, oh, I have to quit sharing my stop share real quick. And real quick, here it is, okay? Does it look correct to you, or is it backwards? It's good? Good. Okay, the word is absent-mindedly. And sometimes we might not be able to figure out the clue from the context or from the text surrounding the word. And so we have to look at the word itself and break it up into its parts. And in this word, we have absent-mindedly. It is broken up into 4 parts. The first part is the word absent. It is a word we know. What does absent mean? It means not there. Mind, what does that mean? Well, that's how we think. You know, it's our brain. It's our thinking. The ED means in the past, and LY means it's a descriptive word, okay? So absent mind or absent-mindedly means to not have your thinking, okay? That's literally what it means, that your thinking or your mind is not in it, okay? Let's go back to share screen. We're going to start reading this. And the strategy we're going to look at this time, we're going to work on, is asking questions. As you get to be a stronger and stronger reader, a more proficient reader, you are going to ask questions all the time. A good reader uses the strategy of asking questions to help him understand every page. And so we're going to do this. We may not get through the story today. We may get close. Let's see what happens. Kayla and Tim met in front of the International Spy Museum in Washington, D.C. What's Miss Keel planning today? Well, I don't know. Maybe something to do with the 4 different kinds of spies. I'll be with you both in a minute. I'm happy to see you two, but there's something very odd going on at the museum, and we're all concerned. What is it? The guard noticed some strange activity during the daily review of the museum's security tapes. We have an advanced surveillance system of cameras and audio recordings running 24 hours a day. You're bugging yourselves? We have some very valuable and rare spy equipment. Remember when someone tried to steal the pigeon camera? Kayla and Tim smiled. In the past few months, they had gotten to know Ms. Keel, first as a tour guide on their museum field trip, and then as a mentor. She had instructed them about the first skill any spy learns, observation. By using the skill of observation, they had helped solve a number of spy cases. The International Spy Museum was their favorite place now, and they discovered new things every time they returned. Besides observation, they had learned about dead drops, brush passes, ciphers, codes, and bugs and listening devices. You can hear breathing on the audio recordings, but the camera takes a picture every 60 seconds and no one is in the photos. Well, how is that possible? Someone or something is definitely here. It's all very strange. Creepy. Anyway, didn't you say you wanted to do something new this week? How about a trip through our ductwork? Cool, let's do it. What's ductwork? That might be something that some of us don't know. What is ductwork? Well, every building has air ducts, whereby passageways whereby air is taken from the air conditioner and forced into rooms. So your houses have it, your apartments have it, and our classrooms have it. How about a trip through our ductwork? Cool, let's do it. Many buildings have ductworks in the ceiling that carry air around the rooms. Remember, this is a graphic novel, so we have the clue about what it means through the picture. Guests at the Spy Museum can crawl into the ductwork and move above the crowds, then watch and listen to those just like spies. Okay, now let's use our strategy. Our strategy to help us improve our comprehension, our understanding, is to ask questions. And I want to ask questions using, I'm gonna stop sharing real quick. But I want you to ask questions using this: who, what, why. Okay? Now, who and what are very concrete. They are something which is extrinsic, almost explicit in the text. But the why is going to be intrinsic. It's going to be something that's implied, something where you have to read through the text or around the text to find the meaning, to find the answer. Okay? Who, what, why for right now. So, why do you think, okay, so it's an inferential question. Why do you think Ms. Keel is asking them if they want to climb or to go through the ductwork? See, she doesn't tell why. She just says, how about a trip through our ductwork? But she has a purpose. Why does she want them to do that? You see, if you get an answer in your head, you can make a prediction about what's going to happen next. Remember, predictions is one of our major tools for the 7 habits of highly effective readers. So let's go on. The adventure starts in the bugs and listening devices area. Visitors climb stairs and crawl along the ductwork as it snakes across the ceiling. The ductwork ends at another set of stairs near the disguise gallery in the School for Spies area. Visitors often hear the banging and clanging of kids in the metal ductworks overhead. Kids can hear people below and can spy on them through the grills built into the duct's metal walls. Kayla and Tim climbed the stairs and followed the signs into the ductwork. They got down on all fours and snaked through the dark, 3-foot wide passage. Every 10 feet, a grill let in some light from below. The voices below echoed through the metal walls. Suddenly, they heard a frantic voice. "They're here again." "Who?" "Those 2 kids. Be careful. They're trouble." "Kayla, they're talking about us." They sounded angry. One of them warned the other to watch out for us. They must be up to something. Okay, here we go. Ask a question. Who, what, why? The question is this: who do you think the people are who are talking about these 2 kids, Kayla and Tim? Who do you think they are? Again, if you answer this time it's inferential, the who. But if you answer this, it will give you a chance to make a prediction, and you are connecting to the story. That in itself helps you comprehend. If I was to ask you a who question, such as who heard someone talking through the grills, you could say Kayla and Tim. That would be extrinsic. It's in the text. It's easy to see. It's concrete. But if I say who is talking, we don't know. Who is talking about these 2 kids? Be careful, they're trouble. Who said that? Then it becomes inferential. They moved through the rest of the tunnel quickly and made their way down the exit stairs. Miss Keel was waiting at the bottom. "How was it?" "It was fun, but we overheard some people talking about us." Kayla repeated the conversation. Then one of them said, "Be careful, they're trouble." It's very peculiar. Let's clear our minds by doing something else. Did you do the reading I gave you about the different kinds of spies? Cloak, dagger, shadow. What was the other one? Ninja. Now, earlier, just time out, but earlier, remember, they referred to the 4 different kinds of spies. Here, and she refers to them right here. Now, we have them listed: cloak, dagger, shadow, and ninja. Okay? The cloak spy is a master of disguise. They can turn into someone else in a few minutes using a wig, makeup, a fake nose, and a new clothes. The dagger spy is someone who likes a little more danger. They must plant electronic bugs or be the one to go in and rescue another spy. Next is the shadow spy. They hide in the background, collecting information from other spies and analyzing it. And my favorite, the ninja spy, they can get in and out of buildings without being seen. They can hide right in front of you. They get what they want and then they disappear like a ghost. Okay, on page 15. Which one of these spies? Now we're making a connection, but it's a question, okay? Which one of these spies would be most like you? Would you most like to do or be good at? That might be something, heads up, that might be something we write about soon. Okay? Page 16. You 2 clearly did your homework. I wish we knew what kind of spies we're dealing with now. First, the mysterious breathing on the recordings, and now we overhear someone who thinks we're trouble. The people who were talking about us might still be here. Do you think they're one sneaking into the museum? I don't know. All I know is that the audio tapes have recorded episodes of the person breathing 4 times. It happens every few days at the same time, just after the museum closes. Is the museum missing anything? Oh, I'm sorry. Is anything missing from the museum? No. Anyway, I should head back to my office. They waved goodbye as they parted. Okay, that's all we're reading today. But I want us to also consider the whole idea of asking questions. Tomorrow, we're going to finish this, and you're going to give me your questions, and then I'm going to give you some questions at the end. We're going to practice asking questions, okay? Now, who, what, why? There are other kinds of questions as well. Where, who, what, where, who, what, why, where, how, when. All of these can be either inferential or extrinsic in their answer. They can be inferred, or they can be very, very concrete in the text. And that's what we're going to work on tomorrow, okay? Okay, at this point, because I don't have enough time to really do the next, and I don't really want to start it with unless I had a chunk of time. They can work on their iReady, can't they? Because I'm not going to give any assignment today.
Okay, yeah, of course. iReady, I just want to explain real quick. iReady suggests that this lesson that I've assigned, it takes about 20 minutes. Some people can finish in 20 minutes. That's great, then you're done. If it takes you longer than 20 minutes, then you can work on it today in class. You can work on it as homework and finish it, or you can spend today and tomorrow working on it as long as you get it done by tomorrow evening. It is due tomorrow evening. So yes, of course, iReady is up and running for them and available.
And we also have iReady to do for reading too.